Oh. Testing. Testing 1, 2, 3. Hello? Okay, audio should be heard. Why is she not moving? Hello? Come on. And my mic is on now. Testing, test. Appreciate it. Is there a lag? Seems like it. How bad is the lag? Oh, okay. Sure, fair. I see movement. Yes. Some movement, hopefully. Hi, hello Mustafa, welcome. I had technical issues. I couldn't get the character to show. And now we're here. Alhamdulillah. Happy Friday. How's it going? I don't know why the old chat is there. Okay, I can see your chat, but it's a bit annoying that the old chat is still there. Can I try to tell it to go away? I don't know. I will give it a minute. If I can't, then we will just let it go, because that's how life is. Chat overlay. There's this hide messages after 30 seconds. Embed. Let me see if I can replace it with that. I don't think I changed anything, but anyway. I was confused by the old chat too. I thought nope. Yes. We will fix this next time, no worries. This is life. So, how's it going? Okay, testing things, looking at things, making sure things are things. Right, let's start. I was first I was late because I was watching someone else's stream. The person who rated us last time. Their stream just started and I was like, I want to join, but then it was my streaming time. So why does my wing look so odd? It looks really sad. Alhamdulillah. I mean, the day is just starting, so I really don't know how I am yet. But inshallah, it's going to be a good day. And I start off doing well, and if the day is mean to me, I may not be well by the end of it. For now, everything's good. Alhamdulillah. So, should we start the studying part? There we go. Oh wow, the wing tip ends look really odd here. It's supposed to be connected, but because of the background, it's all meshed. Can I change the wing? I don't know why I'm bothered by the wing. It doesn't make sense. It is a part of accessory. I like the black wings, but what about this one? This is also supposed to be black. Same. Oh my god, it merged. Was it always this bad? I felt like it wasn't always this bad. How many styles of wings do I have? Yeah, I think this black one is pretty okay. Yeah, looks like bat's wings. Anywho, what are we doing? Why are we here? What's the purpose of this stream? We are just double checking my mic's on. Oh, of course it's on. Okay. We are taking this online course called Introduction to Machine Learning for Coders, which is what we are. We're coders. Taught by Jeremy Howard, a part of the fast.ai courses. And how long have we been doing this? I think we started on September 15th, so it's almost a month and a half. It says it takes 12 weeks. I feel like we're gonna get there. Today's lesson 9. I technically finished lesson 8 the other day, but honestly, I did not look at the notebook, because I couldn't run it the first time, and then obviously I'm lazy, so I didn't run it anytime. So I'm just gonna start lesson 9. I feel like a really passive learner, which is not good, but I am learning stuff. The other day, I was thinking the layers of the it was just a neuron, right? It was not multi-layered, but the parts that I understood, it just made me think of a for loop with different algorithms inside. So yeah, let's look at what we are supposed to be learning today. Okay, that's good. We continue the building of the logistic regression from scratch part, because I guess we didn't finish that. We add the most important feature to it, regularization. We'll learn about L1 versus L2. What's L1 versus L2? I know what L's are in physics. Lagrangian points, right? There's one for the moon. There's one for the point between the moon and the earth, the point between the sun and the earth. I think these are Lagrangian points, right? Anywho, this is computer science, not physics, not astrophysics, and how they can be implemented. We also talk more about learning rates, how learning rates work. I know what learning rates are. They're like error rates, but for learning. And how to pick one for your problem. Is that like evaluation? Oh my god, in the second half of this lesson, we start our discussion on natural language processing. What? We built a bag of words. Oh my god, representation of the popular IMDb text data set. Using sparse metrics, okay, to ensure good performance and reasonable memory use. We will build a number of models from this, including naive Bayes and logistic regression, and we will improve those models by adding n-gram features. Oh my god, this is going to be fun. I need to go and check something, sorry. Be right back. Okay, it's all good. Okay, wow, there's a really bad drop frame rate. Anyway, going back to the learning part. Yeah, the only thing we gotta do is start. That was lesson 8, right? Yes, okay. Lesson 9. Bismillah ar-Rahman ar-Rahim, let's do this. Thanks. Is this from University of San Francisco? Yep, it is from University of San Francisco. Got it. Just double checking. Ooh. Synthetic data set? Is that what he said? Yep. Is it clustering? That's what the color is doing? Question mark. I really like the tree boundary. This is weird, like really cool, but also a little bit. It looks like art, literally, right? Wow. Wow. This is so cool. Wow. Oh my god, it happened again. I keep saying, wow, this is so cool, and you're seeing nothing. Great, lovely, so great. And I thought I was I'm gonna go back because you have to see this. All right, I'm gonna do the explaining part. This is synthetic data. He colored it. That's it. Go forward, and then he drew the decision tree boundaries, right? On what it's split on, I guess. And then he colored those parts in. Look at this. Isn't this literally art? How cool is this? I mean, I hope you can see it. But this is really cool. And then averaging these out, I guess, because these are different parts of the data. And this is what it looks like. Even more art.
Like the fuzzy decision boundaries of a random forest. And I think this is kind of amazing, right? Because it's like I wish I had classes. It's just like, okay, that's what we do. You know, we create the decision boundaries, we average each area, and then we do it a few times and average all of them. Okay, so that's what a random forest does. And I think like this is just such a great example of making the complex easy through
Really
pictures.
beautiful. I agree.
So congrats to Tyler for that. It actually turns out that he has actually reinvented something that somebody else has already done. A guy called Christian Innie, who went on to be one of the world's foremost machine learning researchers, actually included almost exactly this technique in a book he wrote about decision forests. So it's actually kind of cool that Tyler ended up reinventing something that one of the world's foremost authorities on decision forests actually has created. So
it's so cool when teachers encourage students and students, like accept the encouragement and do the thing. Not me though.
I thought that was neat. That's nice because when we posted this on Twitter, it got a lot of attention, and finally somebody was able to say like, oh, you know what, this actually already exists. So Tyler's gone away and started reading that book. Something else which is super cool is Jason Carpenter created a whole new library called Parfit. And Parfit is a parallelized fitting of multiple models for the purpose of selecting hyperparameters. And there's a lot I really like about this. He's shown a clear example of how to use it, right? And like the API looks very similar to other grid search based approaches, but it uses the validation techniques that Rachel wrote about and that we learned about a couple of weeks ago of using a good validation set. And what he's done here is in his blog post that introduces it, he's gone right back and said like, well, what are hyperparameters? Why do we have to train them? And he's kind of explained every step. And then the module itself is like, it's very polished. He's added documentation to it. He's added a nice README to it. And it's kind of interesting when you actually look at the code, you realize, it's very simple, which is, it's definitely not a bad thing. That's a good thing, is to make things simple. But by kind of writing this little bit of code and then packaging it up so nicely, he's made it really easy for other people to use this technique.
Yes, even when you create something, if you don't make it, useful and document it well, no one's going to use it. So it's good that the student has done a really good job of documenting the usage. Yes.
Which is great. And so one of the things I've been really thrilled to see is then Vinay went along and combined two things from our class. One,
okay, stochastic, gradient descent. Okay.
Was to take Parfit, and then the other was to take the kind of accelerated SGD approach to classification we learned about. I thought was actually...
Honestly, teacher showcasing students' work. Like, he must be so proud and so happy. I don't know if I'm sad or really happy right now. I can't tell.
Basically went through and summarized pretty much all the stuff we learned in the random forest interpretation class. And he went even further than that as he described each of the different approaches to random forest interpretation. He described how it's done. So here, for example, is feature importance through variable permutation. A little picture of each one. And then super cool, here is the code to implement it from scratch. So I think this is like really nice post, describing something that not many people understand and showing, exactly how it works, both with pictures and with code that implements it from scratch. So I think that's really...
I feel like I've seen this variance and bias picture in a lot of places. Maybe one place, but I've seen it before.
Really, really great. One of the things I really like here is that for like the tree interpreter part, he actually showed how you can take the tree interpreter output and feed it into the new waterfall chart package that Chris, our USF student, built to show how you can actually visualize the contributions of the tree interpreter in a waterfall chart. So again, kind of a nice combination of multiple pieces of technology we've both learnt about and built as a group.
That's cool. Students using students' things. I feel like a proud parent here.
I also really thought this kernel, there's been a few interesting kernels shared, and I'll share some more next week. Devesh wrote this really nice kernel showing there's this quite challenging Kaggle competition on detecting icebergs versus ships. And it's a
Icebergs versus ships. Huh. Probably from images, right?
kind of a weird two-channel satellite data, which is very hard to visualize. And he actually went through and basically described kind of the formulas for how these like radar scattering things actually work, and then actually managed to come up with a code that allowed him to recreate, the actual 3D icebergs. Or
Come on. Students aren't supposed to be this smart. Yeah, no, they're supposed to be this smart. That's why there's a saying that says the student becomes, smarter than the master, whatever. I don't know. Words.
ships. And I have not seen that done before. Like it's quite challenging to know how to visualize this data. And then he went on to show how to build a neural net to try to interpret this.
Conv, as in what is it? Conventional? No, there's another word. Whatever. Okay, I forgot.
So that was pretty fantastic as well.
Okay, I'm gonna stop. All right, are we starting?
So yeah, congratulations for all of you. I know for a lot of you, you're posting stuff out there to the rest of the world.
There's a convolutional. Thank you, Yuki. Thank you. I felt like a car that wasn't starting. Yes. Convolutional neural networks, CNNs, which are they for images? Anyway. Hi. Yes, also Mustafa said the other thing. Oh wow, yes, wait, you're supposed to be a random bot. Why are you helping me? I was literally about to ban the bot, but apparently they're not a bot. Hello. Yes. Why am I having a hard time saying it? Convolutional neural networks. Yes. Okay. It's cool that he's showcasing students' works. And I guess we're starting where we left off, with the MNIST.
For the first time, and it's posting stuff out there to the rest of the world for the first time, and it's kind of intimidating. You're used to writing stuff that you kind of hand in to a teacher and they're the only ones who see it, and it's kind of scary the first time you do it, but then the first time somebody, upvotes your Kaggle kernel or adds a clap to your Medium post, you suddenly realize, oh, I'm actually...
There are good people out there. Yeah, I am still scared to do blogs. I don't know why blogs sound even more... Is it a tongue twister? I wouldn't say that. It's just sometimes second languages, I suppose third languages, I don't know, aren't easy. And it's okay to forget words.
I've written something that people like. That's pretty great. So if you haven't tried yourself yet, I again invite you to try writing something. And if you're not sure, you could write a summary of a lesson. You could write a summary of, like, if there's something you found hard, like maybe you found it hard to fire up a GPU-based AWS instance, you eventually figured it out.
I think my blogs are, vlogs. Not vlogs, but you know what I mean. Because at first I was scared of the hash code things, and then when I did something that was a resemblance of solving things, I was like, I'm gonna share it with people. And now, honestly, like, one of the things that I want to share with people, which I've been saying for a while, haven't done it yet, is, my streaming setup. Because I didn't build my model, and I'm doing everything for free. Unlike Yuki's very fancy streaming VTuber style setup that is, I'm guessing, all created by you. Which is really cool, honestly. I saw it yesterday, and it was really cool. All the customizations, all the movements, beautiful. Everything so well thought out. But mine is just like someone can do this in a day. It took me a while to get here, but it can be done in a day.
You could write down, just describe how you solved that problem. Or if one of your classmates didn't understand something and you explained it to them, then you could write down.
Raise your hand, which I can't do because my hands don't move. Raise your hand if you've been the person who explains a subject to someone else who's done it at school, or any other place. Me. Yeah, so I guess, or even explaining things for yourself, learning new things. That can be a blog. It's been a while since I've taken physical notes on things that I can look back on, because we were encouraged to do that in school. Yeah.
Something saying,
even learning this, I'm not taking any note. I'm being lazy. Yes.
There's this concept that some people have trouble understanding. Here's a good way, I think, of explaining it. There's all kinds of stuff you could do. Okay, so let's go back to...
Yes, I see your hand, Mustafa. Yeah, so basically these are blogs according to Jeremy Howard, which is, I agree. Explaining things is where we start. I have a friend who's a really good blogger. In record time, the whole curriculum, minutes before the exam. No. I am extremely against this one because, good for you, mashallah, but I am against the, the hurried review before exam part, because it messes with your brain. I don't know, I feel like it makes you forget everything. That's for me. There are people who enjoy doing that. The things you made, because I just selected what my avatar should be. I'm guessing you used platform like I used it once. I sculpted an avatar in the something studio, and it's not Anime Studio, VTuber Studio, something like that. But dude, yours is amazing. It looks like you've put a lot of thought in it. The parts that I've put thought in are, selecting what should be there. Is this creepy? Maybe. By the way, I'm tracking my face on my phone. That's why I can zoom in and zoom out, because it's on my phone.
SGD. And so we're going back through this notebook which Rachel put together, basically taking us through kind of SGD from scratch for the purpose of digit recognition. And actually quite a lot of the stuff we look at today is going to be closely following part of the computational linear algebra course which you can both find the MOOCs on fast.ai or at USF. It'll
What? There's a fast AI MOOC on computational what?
closely following part of the computational linear algebra course, which you can both find the MOOCs on fast.ai or at USF. It'll be an elective next year, right? So if you find some of this this stuff interesting, and I hope you do, then please consider signing up for the elective or checking out the video online.
I probably won't, and then I'll get stuck on something. Ronan, are you a bot or a person? Describe a single convolutional neural network architecture that, given a sentence, outputs a host of language processing predictions. It is not for just images. Oh my god, you should be a person. You're probably a person. Thank you. So it can be used. It's just an algorithm. Thank you. How dare you call me stupid? I'm spooky. Yeah, I can bring the pumpkins back. Mine started as a VR chat avatar. I bought on Booth. A lot of ready-to-use VR chat avatars are sold on that site. Okay, I pick bits and pieces and put them together on Blender. Blender is fun. I know a tiny bit, just a tiny little bit. I can make a chair out of a cube. Yeah. Okay, so it's made with love from a dough. That's cool. Yeah, I guess even if you don't do it from a cube, still, it's made with love. And my character, I just chose the stuff that are there, but I love her. I don't know how to make myself scary, but I can add the pumpkins back. Blender is scary? I don't think so. We have the pumpkins back and the scary ghosts. I don't know if you can see from Twitch, but I have put what app I use. It is called ZE. I mean, I don't know how to read it, but I say ZEPETO, just like GEPETO, but with a Z. It's an app. I think it's Korean, and I know they do a lot of. Come on, what happened to the what's wrong? Wake up, wake up. Am I dead? Shoot. Am I dead? Are we alive or dead? I think I'm alive. Yes. Anywho, they do a lot of brain just went away. Promotion for K-pop. There. Okay, I'm awake now. I just thought my internet messed up. Anywho, yes. So it's an app that is constantly updated. Yes. And they have, outfit changes are not hard. You can do it anytime. And they have seasonal things, like these scary little ghosts. Yeah. Okay. I think the actual lesson is starting in a minute. Let's see if we can get there.
So we're building neural networks. And we're starting with an assumption that we've downloaded the MNIST data, we've normalized it by subtracting the mean and divided by the standard deviation. Okay, so the data is, it's slightly unusual.
Thank you. I saw an error on OBS. It said can't connect, and I was like, I'm done for.
That although they represent images, it's slightly unusual in that although they represent images, they were downloaded as each image was a 784 long
Array?
rank 1 tensor. So it's been flattened out.
I should learn to say tensor instead of array. Ranks of tensors. Okay. I don't know why each time I say tensor, my brain goes tesseract. They're different.
Okay, and so for the purpose of drawing pictures of it, we had to resize it to 28 by 28. But the actual data we've got is not 28 by 28. It's 784 long, flattened out. Okay.
Is it the whole thing? The 784 thing? Or is it just for one picture? Can I look at that again? Yes. Should be the whole thing, right?
Flattened out. Okay.
Okay.
The basic steps we're going to take here is to start out with training the world's simplest neural network. It's basically a logistic regression, right? So no hidden layers. And we're going to train it using a library, fast.ai. And we're going to build the network using a library, PyTorch, right? And then we're going to gradually get rid.
Yes, array does sound less scary. Like, I know array, I know matrix. I'm not friends with them, but I might say hi if I see them. But when you say tensor, and I think you said you don't like TensorFlow, right? Is that what I heard yesterday?
Rid of all the libraries, right? So first of all, we'll get rid of the NN neural net library in PyTorch and write that ourselves.
Cool. We're gonna kill this one and write it ourselves. I had this teacher in uni. He would make us, like, he would give us an assignment, sort of, not really like learning, and he would have us do some string function, and then at the end he'd like, guess what, this already exists. But Jeremy Howard isn't doing that. He's saying, we have this that we can use, let's see how it works. I like his style more, because you see the output, you know what you're trying to create, to imitate.
Then we'll get rid of the fast.ai fit function and write that ourselves. And then we'll get rid of the PyTorch optimizer and write that ourselves. And so by the end of this notebook, we'll have written all the pieces.
It's more complicated, IMO, yeah, and likes to deprecate functions and break things every week. Oh, really? Is it? I haven't used it, so I can't say. I guess you've had some experience with it. I didn't like version 1 of TensorFlow, but version 2 looks a lot better. Okay, so you guys have used TensorFlow. I remember when it came out. I've looked at like the documentation, but this girl is too scared to do anything. Woohoo. I suppose I was never, even when I was using Python, I didn't go that TensorFlow route. Yeah.
Pieces ourselves. The only thing that we'll end up relying on is the two key things that PyTorch gives us, which is A, the ability to write Python code and have it run on the GPU, and B, the ability to write Python code and have it automatically differentiated for us. Okay?
What do you mean by differentiated? I mean, you're going to tell us, but okay.
So they're the two things we're not going to attempt to write ourselves because it's boring and pointless, but everything else we'll try and write ourselves on top of those two things. Okay, so our starting point is like not doing anything ourselves. It's basically having it all done for us. And so PyTorch has an NN library, which is where the neural net stuff lives. You can...
Oh, that's so cute. Is that Yuki? Nope, it's another person.
create a multi-layer neural network by using the sequential function and then passing in a list of the layers that you want. And we asked for a linear layer followed by a softmax layer, and that defines our logistic regression. Okay?
Yes, linear layer and a softmax layer. That's our logistic regression of one. No hidden layers of one whatever thing.
The input to our linear layer is 28 by 28, as we just discussed. The output is 10, because we want a probability for each of the numbers.
Yes, so that we can give it to the softmax layer.
0 through 9, for each of our images. Okay.
Which part about his honesty? Oh, saying that it's boring and we're too lazy to do it? Yeah. Yeah. When the teacher is honest, the students will be honest.
CUDA sticks it on the GPU. And then fits a model. Okay, so we start out with a random set of weights, and then fit uses gradient descent to make it better. We had to tell the fit function what
Fit. Okay.
criterion to use. In other words, what counts as better, and we told it to use negative.
Is fit... Sorry, I feel a bit dumb asking this, but anyone with a tiny bit of Arabic in their blood will confuse bes and but. Tell me if I'm wrong. Anyway, even though I have no Arabic in my blood, I just have it in my brain. Anyway, what was I saying? Is fitting training or not? I'm gonna ask Google that because I'm not sure. Fitting a model versus training, something like that. Yeah. Fit refers to the step where you train your model using your training data. That's so mean. That's so mean.
The details of that we won't cover in this course. We're going to build something simpler called SGD. If you're interested in Atom, we just covered that in the deep learning course.
Training is a process of making the model fit. Yeah, I know the word overfitting because it just sees everything, like it just, yeah, patterns in data, I suppose. Like there is 100% recall, I suppose, because it's taking everything from the training data. So that's overfitting. Yeah, okay, makes sense. Cat or a duck? What happened? Why are we talking about cats or ducks? Why are we talking about cats and ducks?
And what metrics do you want to print out? We decided to print out accuracy. Okay, so that was that. And so if we do that, okay. So after we fit it, we get an accuracy of generally somewhere around 91, 92%. So what we're going to do from here is we're going to repeat this exact same thing. So we're going to rebuild this model, 4 or 5 times, building it and fitting it with less and less libraries. Okay. So the second.
Honestly, there's way too much jargon, and I feel like people do it to scare away new people and screw their jobs. You're cynical. Don't be sorry. I agree with you. I think it's like the scientific jargon, as you say. They do it to sound fancy because when you write papers, you have to make it sound like you are smart for people who may not be in your place. So that's like step one. And then other people use the same thing that the other people used to make themselves sound like they know what they're saying. And then it sticks. And then it leads to the making sure that they're relevant. And people who do science communication are angels because they put it into human language. I've been probably, a part of this because when you write a paper, you have to write it in their language. Otherwise, they're not going to accept it. It's a sad world we live in. Bis or bad in Arabic? Oh! I'm not sure I heard correctly. No, I did not. No. Not both in Arabic. Not batta. No. But in English, as in, but. And, I don't know. I've heard people make that mistake. I've heard Arab people make that mistake of like bus, as in, am I saying it wrong? It's like accept? Is that what it means in Arabic? I wouldn't say it means stop, but something along those lines. Yeah. It's fun when your brain confuses languages. It is fun. And put computer languages in there and it's even more fun. All the languages.
Second thing that we did last time was to try to start to define the module ourselves, right? So instead of saying the network is a sequential bunch of these layers, let's not use that library at all and try and define it ourselves from scratch.
Mm-hmm.
Okay? So to do that,
not using the stance you should hold. I don't know. Do whatever you like.
create a class which inherits from...
Okay. Bas in Egypt means see. Look, in North Africa it's something that doesn't have it. Nice. Okay. Learning new things all around. Huh. Anyway.
nn.module. So nn.module is a PyTorch class that takes our class and turns it into a neural network module, which basically means anything that you inherit from nn.module like this, you can pretty much insert into a neural network as a layer.
Inheriting attributes and functions from the parent class. Yes.
Or you can treat it as a neural network. It's going to get all the stuff that it needs automatically to work as a part of or a full neural network. And we'll talk about exactly what that means today and in the next lesson. Right?
Right.
So we need to construct the object. So that means we need to define the constructor, dunder init. And then importantly, this is a Python thing, is if you inherit from some other object, then you have to create the thing you inherit from first. So when you say super.dunder init, that says construct the...
This thing is called dunder. That's funny. Doesn't that sound Australian?
nn.module piece of that first, right? If you don't do that, then the nn.module stuff never gets a chance to actually get constructed. Right? So this is just like a standard Python OO subclass constructor. Okay? And if any of that's unclear to you, then this is where you definitely want to just grab a Python intro to OO, because this is
constructors. Intro to OO. Oh, what? I never say OO. Why am I saying OO? Object-oriented programming. Oh, we say OOP. Okay, my brain just came back to me.
The standard approach. Right. So inside our constructor, we want to do the equivalent of nn.linear. All right. So what nn.linear is doing is it's taking our 28 by 28 vector, so 768 long vector, and that's going to be the input to a matrix multiplication. So we now need to create something with 768 rows, and that's 768, and 10 columns. Okay? So because the input to this is going to be a mini batch of size, actually let's move this into a new window. (768) by 10, and the input to this is going to be a mini batch of size 64 by 768. Right? So we're going to do this matrix product. Okay. So when we say in PyTorch nn.linear, it's going to construct this matrix for us. Right? So since we're not using that, we're doing things from scratch, we need to...
Oh. We need to do it ourselves.
Make it ourselves. So to make it ourselves, we can say generate normal random numbers with
the dimension that we're getting.
This dimensionality, which we passed in here, 768 by 10. Okay, so that gives us our randomly initialized matrix. Okay. Then we want to add on to this, we don't just want y equals ax, we want y equals ax plus b. Right, so we need to add on what we call in neural nets a bias vector. So we create here a bias vector of length 10. Okay, again, randomly initialized. And so now here are our two randomly initialized weight tensors.
Shoot.
So that's our constructor. Okay. Now we need to is this module in Python.
Wait, nothing happened? I think my avatar froze. Yeah. Yep. Did I mess it up? Did I mess it up? Maybe. Great. Lovely. Okay, I'm gonna let Jeremy do the talking, and I'll fix this avatar messing up thing.
PyTorch, the object that you get back behaves as if it's a function. You can call it with parentheses, which we'll do that in a moment. And so you need to somehow define what happens when you call it as if it's a function. And the answer is PyTorch calls a method called forward. Okay, that's the PyTorch kind of.
Yes. I mean, he's repeating what we did last time, which is great. My brain loves a review, but the forward is basically like you're in a loop and you're doing the next thing, right?
Approach that they picked, right? So when it calls forward, we need to do our actual calculation of the output of this module or layer. Okay, so here is the thing that actually gets calculated in our logistic regression. So basically we take our input x, which gets passed to forward. That's basically how forward works. It gets passed the mini batch, and we matrix multiply it by the layer 1 weights, which we defined up here, and then we add on the layer 1 bias, which we defined up here. Okay, and actually nowadays we can define this a little bit more elegantly using the Python 3 matrix multiplication operator, which is the @ sign. Okay, and when you use that, I think you kind of multiplication using the Python 3 matrix multiplication operator, which is the @ sign.
What?
Okay. And when
That's new to me. Matrix multiplication operator? We have that?
When you use that, I think you kind of end up with something that looks closer to what the mathematical notation looked like, and so I find that nicer. Okay.
What does the mathematical notation look like? I've forgotten that part.
All right, so that's our linear layer in our logistic regression. In our
AX plus B, linear layer. This is our bias, these are weights, and that's our little x.
zero hidden layer neural net. So then the next thing we do to that is softmax. Okay, so we get the output of this matrix multiply. Okay, who wants to tell me what the dimensionality of my output of this matrix multiply is?
The input is 10. Isn't the output also 10? I mean, 28 by 10? I forgot.
Sorry? 64 by 10. Thank you, Karen.
Okay.
And I should mention, for those of you that weren't at deep learning class yesterday, we actually looked at a really cool post from Kerem who described how to do structured data analysis with neural nets, which has been like super popular. And a whole bunch of people have kind of said that they've read it and found it super interesting. So,
Cool.
So that was really exciting. So we get this matrix of outputs, and we put this through a softmax. And why do we put it through a softmax? We put it through and we want for every image, we want a probability that it's a 0. A bunch of probabilities that add up to 1, and where each of those probabilities is between 0 and 1. So a softmax.
That's what Mustafa told me last time. It will be more than 0, and it will be between 0 and 1, right? That's why we are doing this.
Does exactly that for us. So for example, if we weren't picking out numbers from 0 to 10, but instead we're picking out cat, dog, plane, fish, or building, the output of that matrix multiply for one particular image might look like that. These are just some random numbers. And to turn that into a softmax, I first go e to the power of each of those numbers. I sum up those e to the power ofs, and then I take each of those e to the power ofs and divide it by the sum. And that's softmax. That's the definition of softmax. So because it was e to the power of, it means it's always positive. Because it was divided by the sum, it means that it's always between 0 and 1. And it also means, because it's divided by the sum, that they always add up to 1. So by applying this...
It was e to the power of part. Yes, yes. It's always positive, yes. And divided by sum, right? We said that?
It means that it's always between 0 and 1. And it also means, because it's divided by the sum, that they always add up to 1. So by applying this softmax activation function, so anytime we have a layer of outputs, which we call activations, and then we apply some function, some nonlinear function to that maps one scalar to one scalar, like softmax does. We call that an activation function. Okay, so the softmax activation function takes our outputs and turns it into something which behaves like a probability. Right? We don't, strictly speaking, need it. We could still try and train something where the output directly is the probabilities. Right? But by using this function that automatically makes them always behave like probabilities, it means there's less for the network to learn, so it's going to learn better. Right? So
okay. We're always giving it a percentage, basically.
Generally speaking, whenever we design an architecture, we try to design it in a way where it's as easy as possible for it to create something of the form that we want. So that's why we use softmax. Right, so that's the basic steps, right?
that's the review. 24 minutes of, well, not really. I'd say 14 minutes of review.
We have our input, which is a bunch of images, right, which is here. Gets multiplied by a weight matrix. We actually also add on a bias, right, to get a output of the linear function. We put it through a nonlinear activation function, in this case softmax, and that gives us our probabilities. So there that all is. PyTorch also tends to use the log of softmax for reasons that don't particularly need bother us now. It's basically a numerical stability convenience. Okay, so to make this the same as our version up here that uses
we're using log softmax. I see.
log softmax, I'm going to use log here as well. Okay, so we can now instantiate this class, that is, create an object of this class.
So I have a question back for the probabilities where we were before. So if we were to have a photo with work in...
But that's cat dog. We've talked about this. We said cat dog should be 50%.
the same basic.
So if you had a photo with a cat and a dog together and you wanted it to spit out both cat and dog, this would be a very poor choice. So softmax...
I thought we'd do a different type of categorization. Because last time we just had cat and dog, 0 and 1. That's it. Binary.
is specifically the activation function we use for categorical predictions where we only ever want to predict one of those things, right? And so part of the reason why is that, as you can see, because we're using e to the, right, e to the slightly bigger numbers creates much bigger numbers, as a result of which we generally have just one or two things large and everything else is pretty small, right? So if I like recalculate these random numbers a few times, you'll see like it tends to be a bunch of zeros and one or two high numbers, right? So it's really designed to try to...
I mean, doesn't it depend on the decimal points? I feel like it should also depend on the decimal points.
kind of make it easy to predict like this one thing is the thing I want. If you're doing multi-label prediction, so I want to find all the things in this image, rather than using softmax, we would instead use sigmoid. Right? So sigmoid would cause each of these to be between 0 and 1, but they would no longer add to 1. Okay. It's a good question. And like a lot of these details about like best practices are things that we cover in the deep learning course, and we won't cover heaps of them here in the machine learning.
I feel like he really wants us to take the deep learning course, which we might.
Course, we're more interested in the mechanics, I guess. But we'll try and do them if they're quick. All right. So now that we've got that, we can instantiate an object of that class, and of course we want to copy it over to the GPU so we can do computation.
You can do CUDA everywhere? Like just call anything that you made and just call CUDA on it? Wow.
Over there. Again, we need an optimizer. We'll be talking about what this is shortly. But you'll see here, we've called a function on our class called parameters, but we never defined
Yes.
a method called parameters. And the reason that is going to work is because it actually was defined for us inside nn.module. And so nn.module actually automatically goes through the attributes we've created and finds anything that basically we said, this is a parameter. So the way you say something is a parameter is you wrap it in nn.parameter. So this is just the way that you tell PyTorch, this is something that I want to optimize. Okay. So when we created the weight matrix,
choosing better weights. Yes, that's the parameter.
we just wrapped it with nn.parameter. It's exactly the same as a regular PyTorch variable, which we'll learn about shortly. It's just a little flag to say, hey, you should optimize this. And so when you call net2.parameters on our net2 object we created. It goes through everything that we created in the constructor, checks to see if any of them are of type parameter, and if so, it sets all of those as being things that we want to train with the optimizer. And we'll be implementing the optimizer from scratch later. Okay, so having done that, we can fit, and we should get basically the same answer as before, 91.
One epoch. Oh, okay.
1-ish. So
91-ish.
well, that looks good. All right. So what have we actually built here? Well, what we've actually built, as I said, is something that can behave like a regular function, right? So I want to show you how we can actually call this as a function. So to be able to call it as a function, we need to be able to pass data to it. To be able to pass...
Wait. We can... Wait. Are we... What is this 90% without... Don't we have an X? Yeah. What are the images?
Data to it, I'm going to need to grab a mini batch of MNIST images. Okay, so we used, for convenience, the image classifier data from arrays method from fast.ai. And what that does is it creates a PyTorch data loader for us. A PyTorch data loader is something that grabs a few images and sticks them into a mini batch. And we call these things generators. Generators are things where you can basically say, I want another, I want another, I want another, right?
Okay.
There's this kind of very close connection between iterators and generators. I'm not going to worry about the difference between them right now, but you'll see basically to turn, to actually get hold of something which we can say, please give me another of, in order to grab something that we can use to generate mini batches, we have to take our data loader, and so you can ask for the training data loader from our model data object. You'll see there's a bunch of different data loaders you can ask for. You can ask for the test data loader, the train data loader, the validation loader, augmented images data loader, and so forth. So we're going to grab the training data loader that was...
I don't know why the word data loader sounds funny to me. Okay. Iteration generator. Okay.
Created for us. This is a standard PyTorch data loader. Well, slightly optimized by us, but same idea.
Cool.
And you can then say, this is a standard Python thing. We can say, turn that into an iterator. Turn that into something where we can grab another one at a time from. And so once you've done that, we've now got something that we can iterate through. You can use the standard Python next function to grab one.
Oh my! It looks like it's like when you iterate on a list of objects in Java, right? We have the if there's next, give me next, whatever, all of that.
One more thing from that generator. Okay.
But when you say generator, does that mean it's generating something, or is it getting our thing? Because MD is our data.
So that's returning the X's from our mini batch and the Y's from our mini batch.
Mini batch MB. Is it a subset? Isn't it? Okay, X's and Y's.
The other way that you can use generators and iterators in Python is with a for loop. I could also have said like for.
Yes, I love for loops. Sorry for screaming.
Or, you know, X mini batch, comma Y mini batch in data loader.
Yes, yes. It's basically a for each.
And then like do something, right? So when you do that, it's actually behind the scenes. It's basically syntactic sugar for calling next.
Syntactic sugar. That's funny. But a for loop is more, you know, easy to understand in my brain.
Lots of times. Okay. So this is all standard Python stuff. So that.
Okay, so he prefers using next and iterating that way instead of for loop. That's fine. Cool thing about generators is it can act like a list like that, but without having to have the entire list load into memory. Oh my god, no way. It makes and provide each element on demand. That's cool. I didn't have information. I really feel sorry for having you explain things to me, but also I'm really thankful. So thank you. You need to write a blog. Because you can explain things well.
It returns...
So for loops are, costly on the memory, right?
A tensor of size 64 by 784, as we would expect, right? The fast.ai library we used defaults to a mini batch size of 64. That's why it's that long. These are all of the background 0 pixels, but they're not actually 0. In this case, why aren't they 0? Yeah, they're normalized, exactly, right? So we subtracted the mean divided by standard deviation, right?
Subtracted the mean divided by standard deviation. Okay.
So there it is. So now what we want to do is we want
Generators were a bit confusing for me at first because they were so different to anything I've done before. Thank you. Okay, I'll try not to apologize. But I don't mind it.
to pass that into our logistic regression. So what we might do is we'll go...
By the way, which is a scary place to be, there's a... Am I logged in? There are all the notebooks that he's working on. He's currently on the notebook lesson 4. I couldn't run it last time I tried, but if you want to give it a go, you can. I should be able to send you the link of the original one. What's happening? I mean, if you just say Fast AI Machine Learning Lesson 4, there, that's the real one that someone made. So I'm gonna put it in the chat if anyone wants to go there. And you know, you can just you can edit a copy and just run it. That's it. That's the main idea, but I had an error somewhere.
Variable xmb equals variable. Okay, I can take my x mini batch. I can move it onto the GPU because remember my net2 object is on the GPU, so our data for it also has to be on the GPU. And then the second thing I do is I have to wrap it in variable. So what does variable do?
Oh, I don't know. What does variable do?
This is how we get for free automatic differentiation. PyTorch can automatically differentiate pretty much anything, right? Any tensor. But to do so takes memory and time. So it's not going to always keep track. Like to do automatic differentiation, it has to keep track of exactly how something was calculated. We added these things together, we multiplied it by that, we then took the sign, blah, 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 right? You have to know all of the steps because then to do the automatic differentiation, it has to take the derivative of each step using the chain rule, multiply them all together, right? So that's slow and memory intensive. So we have to opt in to saying like, okay, this particular thing we're going to be taking the derivative of later, so please keep track of all of those operations for us.
Cool.
And so the way we opt in is by wrapping a tensor in a variable, right? So that's how we do it. And you'll see that it looks almost exactly like a tensor, but it now says variable containing this tensor, right? So in PyTorch, a variable has exactly identical API to a tensor, or actually more specifically a superset of the API of a tensor. Anything we can do to a tensor, we can do to a variable. But it's going to keep track of exactly what we did, so we can later on take the derivative. Okay?
Okay.
So we can now pass that
VXMB
into our
variable of our mini batch of the X. Okay.
net2 object. And remember I said you can treat this as if it's a function.
This is our logistic regression CUDA, and this is also on GPU.
Right? So notice we're not calling dot forward.
No.
We're just treating it as a function. And then remember we took the log, so to undo that I'm taking the x, and that will give me my probabilities.
Huh.
Okay? So there's my
Okay.
probabilities. And it's got return something of size 64 by 10. So for each image in the mini batch, we've got 10 probabilities. And you'll see most probabilities are pretty close to 0. Right? And a few of them are quite a bit bigger, which is exactly what we would hope, right? Is that it's like, okay, it's not a 0, it's not a 1, it's not a 2, it is a 3, it's not a 4, it's not a 5, and so forth. So maybe this would be a bit easier to read if we just grab.
I'm a bit lost. I mean, yes, but also no. Somewhere in between.
I mean, we could call like net2 dot forward, and it'll do exactly the same thing, right? But that's not how all of the PyTorch mechanics actually work. It's actually, they actually call it as if it's a function, right? And so this is actually a really important idea, like, because it means that when we define our own architectures or whatever, anywhere that you would put in a function, you could put in a layer. Anywhere you put in a layer, you can put in a neural net. Anywhere you put in a neural net, you can put in a function. Because as far as PyTorch is concerned, they're all just things that it's going to call, just like as if they're functions. So they're all like interchangeable.
So, according to PyTorch, everything is a function. That's pretty cool.
This is really important because that's how we create really good neural nets, is by mixing and matching lots of pieces and putting them all together. Right? Let me give you an example. Here is my logistic regression, which got 91 and a bit % accuracy. I'm now going to turn it into a neural network with one hidden layer. Right? And the way I'm going to do that is I'm going to create one more layer.
Okay. How do we make it hidden?
I'm going to change this so it spits out 100 rather than 10, which means this one input is going to be 100 rather than 10. Now this as it is can't possibly make things any better at all yet. Why is this definitely not going to be better than what I had before?
Because you're doing the same thing twice, right?
Yeah. Can somebody pass the...
Do we get random weights again? Or does it take weights from the above layer?
Because you've got a combination of two linear layers, which is just the same as one linear layer with different parameters.
Exactly. Right. So we've got two linear layers, which is just a linear layer. Right? So to make things interesting...
Two linear layers are basically just a linear layer. Okay. 1 + 1 = 1.
I'm going to replace all of the negatives from the first layer with zeros, because that's a nonlinear transformation. And so that nonlinear transformation is called a rectified linear unit.
Didn't know that.
Okay, so nn.sequential simply is going to call each of these layers in turn for each mini batch, right? So do a linear layer, replace all of the negatives with 0, do another linear layer, and do a softmax. This is now a neural network with one hidden layer. And so let's try training that instead. Okay, our accuracy is now gone up to 96%.
Whoa.
Okay, so this is the idea, is that the basic techniques we're learning in this lesson, like, become powerful at the point where you start stacking them together. Okay, Can somebody pass the green box there and then there? Yes, Daniel.
Why did you pick 100?
No reason. It was like easier to type an extra 0.
God, he's so cute. I'd say 100 looks cool, but easier to type a 0 is also a reason.
Like this question of like how many activations should I have at a neural network layer is kind of part of the skill of a deep learning practitioner. We cover it in the deep learning course, not in this course.
Okay.
When adding that additional, I guess, transformation,
Additional layer?
additional
Without an activation function, true. So he's transforming the negative numbers to 0. So that's a different change.
layer.
This one here is called a nonlinear layer or an activation function.
Oh, so that's what an activation function is.